Ken, are you recording video? Hopefully he's recording video in the other room. All right.
You think that's what he's doing in the other room. Mm-hmm. You ever wonder
if he's doing anything else, he can just stay in that room. I don't need to see that. Here we go. Hold on. Yeah, thumbs up from Ken. Hi, everybody. Welcome to the PC Perspective Podcast. This is episode 139 for January 27th, 2011. I'm Ryan Shrout.
I'm Jeremy Hellstrom.
I'm Josh Walrath.
And I'm Al Malventano.
And welcome back once again. It's another exciting adventure into the world of computer hardware. This week we have all kinds of good stuff to talk about. We're going to talk about graphics cards, at least a couple of different ones. We're going to talk about 3 terabyte hard drives and firmware. Firmware is always exciting. I think we can all agree on that. Tegra 2 and beyond, maybe an Intel SSD or Intel 310 SSD preview. Depends. I don't know if we'll have time. It's a busy little Saturday. But let's jump into the news and technology and whatchamahoo's it. Somewhere around here, I had the card as a demo. We kind of showed it last week, I guess. Did we talk about the WHDI card last week on the show? I feel like we did, but only in kind of like a preview format.
So the Cthulhu came from.
Okay. So did we go through the entirety of it? I mean, did we go through the whole how the video worked, how the video looked, and all that kind of stuff? Because if so, I mean, I'll just move on. Anybody remember?
Yeah, you kind of talked about it ad nauseum. It was awesome.
Okay, well, okay, it's
you
still
out that 3D man.
Yeah, all right, sounds good. So skipping that, then, if you didn't, if for some reason everybody else on the show is lying to me and we didn't talk about it enough, make sure you go to PCPro.com and check out the review of the WHDI Galaxy Geforce Gtx 460 WHDI card, wireless high definition. It was pretty cool. Check out that, and we have a video review of that as well. Next thing we wrote about, Ken actually published a review of the Samsung Galaxy Tab. This is an Android-based tablet. He's not on the show to talk about it because he doesn't want to be famous, internet famous like the rest of you guys. So he doesn't want his face plastered all up on our show. But go over there, check out his review, kind of compares with the iPad, talks about the software. It basically kind of works like a giant Android phone. Take that as you will, good or bad. I think it's pretty cool. It's been useful around the office for lots of different instances. 3G connectivity is always good for that kind of stuff.
Was that the one you were holding up to your head like a cell phone a couple episodes ago?
That was probably that or the iPad. I'm going to go with that. Yeah.
Yes.
Probably that. We had it at CES, so anybody that was there probably remembered seeing it. We probably didn't.
He held it up to his head over there too.
Yep.
Yeah. It seems to be a common trait with me, holding tablets up to my head. People get a kick out of it. So we've got some performance benchmarks, an overview of kind of the software package that Samsung has. It's very familiar if you've used any of the Galaxy S phones, as well as the tablets, that type of thing. So go over there, check it out. Make Ken feel better for writing these articles. You can send him comments. He has a fancy email address, kaddison@pcpro.com. Send him all your complaints, too. They don't have to be nice. Other than that, let's move on to some newer things. Drobo 3 terabyte firmware pushed up. I assume that means released. I don't really want to get into the semantics of pushed up.
Well, okay, so it was going to take longer originally, we thought, for this to come out because Drobo has a pretty strict QA cycle on their firmware before they push out any firmware. So just from what I had heard before, it was going to take them they were going to release greater than 2 terabyte firmware for some model and then wait a couple of months to get through the cycle on the next model and then push that one out. So it seems they have figured out how to speed that process up specific to this. I guess it was probably not as drastic of a tweak as they originally thought to their firmware and didn't have as bad of an effect or as many side effects as they originally thought. So Drobo FS and Drobo Pro FS already has a firmware out for greater than 2 terabyte drive support.
Okay.
The Drobo S model, this includes the second generation model that just came out that also supports USB 3. That firmware is also available. And then in February, they're shooting for Drobo Elite and Drobo Pro. And then in March, they're going to, I guess, backfill on what's almost a legacy model, the original 4-bay Drobo.
Right.
So that's pretty cool, actually, that the original 4-bay Drobo can support 3 terabyte drives. That's pretty good just by itself.
So this is natively, right? Because I know that the first time we looked at the 3 terabyte card, you had to have the controller card with it, right? So this is completely native, no complications with it, right?
Yeah, no, none of that. The only reason you need that HBA, that special adapter, is just because of driver level support mostly for Windows and for the OS level support. So this is essentially Drobo's own OS level support via their firmware for those drives. It's just a matter of you have greater than a 32-bit number for addressing the drive as far as number of sectors.
Gotcha.
Yeah. So I have verified on my end that this range of firmwares works on both Western Digital and Seagate as far as drives that are 3 terabytes in size. Works like a champ. And I expect the same thing to happen for the Drobo Pro. I'm excited that it's that soon, that they're shooting for just next month. There'll be Drobo Pro and Drobo Elite 3 terabyte. So that you can have a 21 terabyte Drobo.
It's not enough. It's not enough for you.
So a catch. There is a minor catch there. The largest you can format a partition on a Drobo, on an 8-bay Drobo, is 16 terabytes. That's the largest it supports.
Okay.
Now, you can format multiple, you can make multiple volumes that all point to the same storage pool. So you would basically just have to make a D drive and an E drive, even though whatever you put on the D or the E, it all goes to the same place. It would be on separate partitions.
Gotcha.
And that 16 terabyte number is a 2 to the n number. It's not a hard drive math number. So it's actually, the equivalent of around 10 2 terabyte hard drives. Right? It's about 20 terabytes in reality. That whole funky hard drive math thing?
Right.
Yeah.
Huh. All right. So anybody that has one of these, look forward to this, and you can have as much storage maybe as Alan. Probably not, but maybe getting closer. The other big release this week was obviously another graphics card, the Geforce GTX 560 Ti. Now I'm going to go around in a poll here. Do you call this the 560 Ti or the 560 Ti? Josh, you first.
Titanium.
You say the whole word titanium.
Titanium.
Okay, that's wrong. Alan, what do you say?
I read that as titanium just looking at the label. So I don't know what they're going for.
Jeremy?
You've seen the periodic table of elements, right, Ryan?
Yes, I have.
TI is titanium.
Yes, I realize it sounds like a TIE fighter.
No scientist in the world is going to look at TI and say that's TI. No, they're going to say titanium. They're going to take that extra 0.5 seconds and say the entire damn name.
I understand that it stands for titanium.
What kind of scientist are you?
I want everybody to understand that. However, the internal debate in NVIDIA is not whether or not to call it titanium or something else. It's whether or not it's 560 Ti or 560 Ti. So those were the two options I was going for here. Not titanium. Everybody fails the test. I'm going to call it the 560 Ti. This is the reference card. It looks very much like the GTX 460 or the GTX 450. Not much to it. It's kind of your now standard kind of NVIDIA reference card design. Nothing too magical going on here. The GPU in here is 384 CUDA cores instead of 336, which is what the GTX 460 has. Now, these are the same GPU pretty much. GTX 460 was called the GF104. This is the GF114. And really the only difference is that it has all 8 SMs, simultaneous multiprocessors, enabled rather than having one of them disabled. So that's where you get to 384 cores instead of the 336. So that is the reference design. Still requires 2 6-pin power connections. Still only has 1 SLI connection. Real quick kind of performance metrics. We're talking 30% or so, 30 to 35% better than the GTX 460. Using a little bit more power, but it's more power efficient overall in terms of performance per watt than the GTX 460, so that's always a plus. Base clock speeds, according to this label on this reference card here, are 823 megahertz on the core speed, 1,000 megahertz, 1 gigahertz on the DDR5 memory speed. Now, that's all good and everything. In my testing, it's it's a little bit better than the Radeon 6870. Yes, that's correct. A little bit better than the Radeon 6870, but slower probably than the 2 gigabyte Radeon HD 6950. AMD, however, of course, as is usually the case, whenever one vendor is going to release a card, the other vendors make sure they have something to compete. The 6950 came out in a 1 gigabyte version, literally 1 hour after the GTX 560 Ti was released. Basically the same price. The 560 is $249 starting price. The 6950 1 gig is supposed to be $10 more at $259. The 6950 1 gig consistently outperformed the NVIDIA card. I think of our 7 or 8 tests, only one of them was the 560 faster. That was Lost Planet 2. So the AMD did a good job in getting a response ready. And even though in my article I actually say that I feel like this is a last minute response, I actually got a call that day the reviews launched from somebody at AMD that said, no, we've had these products available since August. We're holding on to them to wait for the right moment to release it. That makes me angry that they would hold on to a really good product until they just needed an answer, obviously. But if that's the case, it doesn't really matter. All of this is coming out at the same time. GTX 460s are going to be phased out. What's kind of out in the market now is out in the market. There will be, I'm not saying if you own one and you want SLI, you need to buy it today, but probably in the next couple of months, you want to make sure that you have all the stock that you're going to want to have for that. Like I said, base clock speed, what did I say, 823 megahertz, kind of odd. We have 3 retail cards here that we're finishing up a video right now. That's what Ken is doing in the other room this evening, looking at. We have a Palette graphics card. This is the highest overclocked model we have in stock. This runs at 900 megahertz core speed. We have the MSI Twin Frozer 2. It probably has a super pipe on it too, Josh.
Super.
It runs at 880 megahertz core speed, and then we have this Galaxy card that really just barely runs over the reference clock speeds. This runs at 835 megahertz. It's kind of interesting. It has Galaxy's new thing is these fold-out fan designs. This is very similar to that. The screws are in here too tight, so I can't pull it out right now. But just the fan blade itself actually folds up, not the whole casing itself. I can change a little bit on the video here, just so you guys can see. Again, it's kind of, it could be just considered kind of gimmicky. Just nice to be able to maybe vacuum out the heatsink on there without having to take the whole thing off. You can see the screw at the top there, and then it folds down on the hinges at the bottom there. Kind of interesting. Both the Galaxy card and the MSI card are currently priced at the $249, and then the Palette one is $269, considering it is the fastest clock speeds. NVIDIA was kind of telling us before launch, you definitely need to get a hold of this Gigabyte card. It's going to have a clock speed of 1 gigahertz. And sure enough, Gigabyte sent out this press release about their 1 gigahertz model of the GTX 560. But I haven't seen it for sale yet. And the highest I was able to overclock any of these cards was like 975, 980 megahertz. Pretty much a hard stop there on any of these cards. So the fact that somebody was able to get a gigahertz out of it enough that they wanted to sell some tells me that they are bidding these pretty strongly, I guess, if Gigabyte's willing to put that out there and sell it. Or we got 3 or 4 bad samples, which I don't think is the case. So, and for example, the MSI cooler on this is probably the best cooler of the retail cards we've seen so far. We've seen this design on the 460 Hawk, we've got a 6950 Twin Frozer down here we're testing as well. And its loaded temperature was like 65 degrees Celsius, whereas on the reference one it was like 85 degrees Celsius. It was literally like a 20 degrees Celsius difference, and we were still only able to get 975 megahertz out of the GPU on this MSI card. So good cards.
Quick question on reference.
Yeah.
So you said that 560 looks an awful lot like a 460?
It's a little bit, yeah, it's close.
Okay. Well, I'm just asking from a water block perspective, because there might be people like listeners that do water cooling and they're wondering if they can slap a
Or it could
460
be like
water
Allen.
block on a 560? Like, are all the chips in the same place, basically?
I'm going to say
They're pretty much identical.
Yeah,
as far
I don't know.
as I've been able to see. No, yes, no, maybe.
You got to be careful with water blocks. Some of those blocks,
the
one
chip
block.
is the same size. The chip is the same size. It's just a matter of whether or not the mounting holes are in the same location. I would guess that they are. The PCBs might be a little bit different, but I would think that the GPU and memory are probably in almost the exact same location. I don't want to say for sure yet. I don't have a 460 reference card here where I can rip apart and match up piece for piece, but I'd say it's pretty close, if not exactly the same. I can let our reader / Alan know that without a problem.
Okay.
We'll get back to you. So good card, $250. It's one thing you got to keep in mind is that you can get a 1 gigabyte GTX 460 now for like $180 pretty regularly, and if you get them on special, maybe even a little bit less than that. So it's a pretty hefty price difference from it to the 560 for that 30% performance difference. Go to PCPro.com, obviously the one most wonderful hardware review website in the world. Look at the benchmarks, look at the reviews, see what games, what resolutions you're running at, that type of thing, what kind of matches up the best, and go from there, I guess. Any other questions from the crowd?
To kind of go off on a side on this, it certainly looks like NVIDIA has really warmed up nicely to TSMC's 40 nanometer process. Certainly, the original Fermis were, hot, had issues even just getting out of the getting off the blocks, and so it's nice to see that because we had heard so much about AMD really redesigning their chips to work effectively on this somewhat troublesome process. So it certainly seems like NVIDIA has, they were not standing still throughout 2009 and 2010, right. And we finally have the GTX 500 series, which is the 570, the 580, and now the 560, all of which are much better cards than previous, faster, and, run cooler and more power efficient.
They definitely do. They definitely do. No doubt there. It's good to see that the competition is actually pretty strong or pretty competitive now. That's a horrible sentence. The competition is competitive between what AMD is offering and what NVIDIA is offering in all realms: pricing, performance, power consumption, all that kind of stuff. So it's good news. Before we move on to the rest of our stories and news of the day, we'll take a quick second here and break for a word from today's podcast sponsor. Dramatic pause is complete. We thank MSI for their support of the PC Perspective podcast. And I've got a couple of other things we're going to talk about. First, I'll just mention here, there was a review of the Asus wow, there's a lot of letters and numbers. Let me get this right. G53JW-3DE Core i7 GTX 460M 3D Vision Gaming Notebook. It's a lot of words. Yes, all of those letters. A pretty nice 15.6 inch laptop, 6 gigs of memory. The GTX 460M has 1.5 gigs of frame buffer, a Core i7 740QM. This is not a Sandy Bridge notebook, just so everybody understands that. Those revisions are just now coming out. 750 gig, 7200 RPM drive, Blu-ray combo, nice, 5.0 speakers. They call it 7.9 pounds, so don't plan on, maybe hiking for the rest of your life with it. The review unit, as we received it, MSRP of $1,559 from Asus, which is reasonable. But if you get the non-3D version of this laptop, it's $1,199, which is actually a pretty good price considering all the hardware you're getting in there. The Core i7 quad-core CPU, GTX 460M, 6 gigs of memory, huge hard drive, all that kind of stuff. Not an SSD, but pretty good. Also, the design on it is really kind of, it's either going to like it or you're going to hate it. It kind of is let's model this after a stealth airplane type of design. If you look through some of these pictures, it has a lot of sharp angles to it. It has a really, what I think is a cool looking, like gray matte paint job. Plastic, I'm sure it's not really paint, but, a finish to it.
You mentioned it wasn't totally popular in that review, though.
Yeah, no, I know. It's like I said, you're either going to hate it or you're really going to like it. I think it looks cool. It stands out. If you're carrying around a 15.5-inch, 8-pound laptop, anyway, it's not real svelte type type notebook. Matt Smith did a review on that. Go to the website, check it out if you are interested in a gaming notebook. That, again, if you get the non 3D Vision version of it, he wasn't real impressed with the 3D Vision technology on it because it's a lower resolution screen when you get into that in order for the costs to work out. But if you get the basic non 3D version for $1,200 or so, that's a pretty good deal for the mobile gaming hardware you get there. We're going to talk Tegra 2 in a second, and Alan's going to maybe preview a little bit about an upcoming SSD article he's working on. First, I wanted to ask a question. I assume most people on this panel have heard about the Catalyst 11.1a driver. I think it was actually just released to the public today. Is that correct? I think I saw that email come across our desks.
Yes, Andrew Dodd, extraordinaire.
Extraordinary.
Let us all know that 11.1 and 11.1a hotfix are available.
So the hotfix 11.1, it's a new year, time for the first Catalyst driver for January. All good. Performance advantages plus. There's an interesting little new feature implemented in this, at least partially, and it is a new slider bar, control bar for tessellation. And here's what I understand this will do eventually. Right now, it is kind of a dead feature. You can move the bar around, but it doesn't actually do anything. It will be adjusting tessellation performance based on profiles that AMD has created based on individual applications. What that means is if a game developer makes a game with X amount of tessellation going on, right, and AMD feels that it's adversely affecting the performance of their cards, and they think that they can lower the amount of tessellation or adjust the type of tessellation that's being done without affecting image quality, but yet improving performance on their cards, they will do so. When you say it like that, it seems kind of pretty kosher. The counter argument, especially coming from the NVIDIA camp, is what they're doing is they're because their tessellation performance is not as good as NVIDIA's cards, what they are attempting to do is alter what the developer and coder had intended the image to look like so that performance will increase to the level where they can compete with NVIDIA's products. We can kind of say this is analogous to the many times and many very, very complicated discussion about texture filtering, hacks, cheating, quack, all this type of stuff. I'm curious kind of what everybody's feedback on this would be. Again, it's not actually implemented yet because there have been no, as of 11.1, there are no profiles for tessellation, but they are putting that option in there to get people acquainted with it. My guess is to get this discussion going, and hopefully if there's any negative feedback, they can squash it by the time they actually start implementing the feature. Anybody have any thoughts on this one way or the other?
Sounds nefarious.
Yeah.
I don't have any other comments other than that, and I just want to say big words. But what else is new?
I'm for it. I'm for it, but only in a user tweaking perspective, not a benchmark or comparing versus NVIDIA or any other perspective.
Okay.
I would leave that slider completely. They should, first of all, the default. This should be something that only alters it when the user wants a little bit more. That's not going to be the case.
I should have pointed out the default will be AMD optimized, which is that allows them. The default is that their driver will be allowed to alter the tessellation as they see fit.
Then that's basically a cheat.
Now now the counter is there's a slider. You can disable it if you want. If you're a user that is going to be intelligent enough to maybe notice those differences and wants to see that, you have that option to turn it off or even increase it to a higher form.
Yeah, because next thing you know, you're going to be playing Lost Planet 2, and you're going to be swearing you're playing Minecraft. It's untessellated.
Totally untessellated. Jeremy, were you going to say something there?
Yeah, well, I've been playing with the newer one since Tweakown posted it earlier last week. The beta version of it. And, I can totally see where you're coming from, especially because, yes, AMD optimized is ticked right off the bat. Right now it doesn't matter so much because there's no profiles. Eventually it will, where all of a sudden you're going to be, oh no, I get dozens of more frames per second than you do. And unless you're actually willing to sort of look and say, yeah, because the tessellation has been cut way down, you can turn that off, and then you get a slider, which is exactly like the filtering. There's the anti-aliasing slider that they used to have, balance for performance or balance for quality. Yep. Or you can turn it to use application settings to let the actual application grab it. If they just left it on application settings right off the bat, not AMD optimized, I'd be all for it because, hey, it's another slider for me to play with. Goes from 0 to 64X. Turning on AMD optimized right off the bat, yeah, that's dirty pool.
Yep.
Okay. Now, it's funny because AMD is obviously saying we're doing this for the benefit of our consumers. It's no different than us optimizing anti-aliasing routines in the driver or adjusting texture filtering, that type of stuff. The issue is going to be when this starts happening, our consumers, our reviewers, going to be able to tell the difference between AMD optimized, excuse me, and leave my game alone, those settings. And that's kind of what it's going to come down to is, are these settings really taking away from what the game developer, creator, artist is trying to do? That's what I think it will come down to. But obviously, NVIDIA not saying that. They're saying, hard fist. They're changing what the game developer is doing. They are modifying what the intent of the game is supposed to be, and so they're cheating because our tessellation is better. Don't forget that. So let's talk to Josh about Tegra 2 and beyond. We've already been talking about Tegra 2, I guess, in regards to the upcoming tablet devices, the super phones as they're calling, or the super tablets even. NVIDIA likes to create marketing terms, if nothing else. Some news has come out in the last week or two about what's coming next for Tegra. So we don't even have products really released on the Tegra 2 yet, or even a lot of them. We just saw them at CES 3 weeks ago, but some information has come out about like a quad-core version. Is that right, Josh?
That is correct. NVIDIA has their 2009 was pretty much a sucky year. I mean, they weren't able to get Fermi out. The Tegra 1 was late. It was integrated in, I think, one product, the Microsoft Zune, correct? Zune, not
it's a
Zuni.
Great product. It's a Zune. It's a great product.
Zune. Because I always think Zuni and think of the rockets under the aircraft in World War II, the unguided Zunis. Anyway, I'm all about segues tonight. But, 2009 was a crappy year. 2010 started to look up. They got Fermi out. They got the GTX 460. They really hit their stride with the GTX 500 series with the graphics, and they also were able to ship off samples of the Tegra 2, and actually more than just ship samples, but they were able to ship off a bunch of parts to integrators like LG and Motorola and all these other fine folks that will be integrating these products into their cell phones and tablets. And so Tegra 2 has been really an unparalleled success for NVIDIA. I mean, certainly, they've had a lot of success in graphics, but chipsets they did well in. They were not overwhelming, but CPUs it's a totally new line, obviously, for them, right. And they've hit this one apparently out of the park. They were able to ship these products out a couple months before TI, which has the OMAP 4000 series, which are going to be, I think, dual-core as well, based on the Cortex A9 architecture from ARM. And they've got like a 1 to 2 month, possibly 3 month head start on that. And when you're talking cell phones, which get updated and upgraded all the time, I mean, that's really huge. And plus, their expertise in graphics has given them another boost up. But we've also seen that this is not the end of the line for them. I mean, we all know that eventually they will produce other parts, but only now do we realize fully what they are. There's going to be the Tegra 2 3D, which is going to be a slightly more optimized version. It's going to run at 1.2 gigahertz as compared to the 1 gigahertz. It's going to support 3D screens. So like the Nintendo 3DS, which has the glassesless screen 3D screens, Apparently, we're going to see a lot more of these in other handheld devices and possibly from cell phone manufacturers as well, but that will allow you to, see 3D seams without having to wear bulky glasses or polarized lenses or anything like that. So it's going to be a slightly higher performing part that will allow decent frame rates in these new 3D type applications, and the big one is the Tegra 3, which they leaked out this news. I mean, it's obviously not official from NVIDIA, but I think that they certainly don't mind that people are hearing about it. But the Tegra 3 is going to be up to a quad core part running at 1.5 gigahertz. Now you think, wow, it's a big jump from a single core ARM architecture to a dual core and then to a quad core, all in about 2 years. But if we look at ARM at what they've done, when they designed the Cortex A9 architecture, they designed it to be able to be used as a single, dual, or quad core part up to 2.5 gigahertz in speed. Now, obviously, a cell phone at this time is not going to have a quad-core part running at 2.5 gigahertz. That would be like a 15 to 20 watt TDP part, and so obviously you're not going to be doing that in a handheld device. You might do it in a tablet, but your battery life is just going to stink horribly, and plus it's going to be a little too hot for something in a tablet style case. But this appears to be a 28 nanometer part. All indications point to it being a TSMC part, even though GlobalFoundries has made a big deal about 28 nanometer and them working with ARM. So far as I've heard, GlobalFoundries just doesn't have a product line that is able to do what TSMC is able to do in the same kind of timeline. So we're looking at 2012 for any kind of GlobalFoundries part, but TSMC is going to be starting to throw out samples probably late summer of 2011, and NVIDIA is going to ship these samples to us partners in Q4 of 2011. So you probably won't see the full quad core part in a handheld. That'll probably be a dual-core edition. It's going to have, of course, the lower TDP, but they're both going to have a much improved graphics component. Estimates are ranging from about 3 times the speed of the original, not the original, but of the Tegra 2, which, if we kind of look at what Tegra 2 is right now, that's still 20 to 30% faster than, I think, the next fastest, which is the Imagination Technologies parts, the SGX 450, I believe. It's a whole lot faster than the Qualcomm part, which is, I believe, the Adreno 205 is, I believe, the product. And I mean, those are the two biggest competitors that NVIDIA has right now in the space. And the kind of funny thing about the Adreno is that was technology that was bought from AMD by Qualcomm to utilize in these system on a chip. So I know that AMD this past quarter has been kicking themselves for selling off all of their integrated and ARM-based stuff. But the one thing that we need to remember, that while NVIDIA is great at marketing and press releases, and they have a very close relationship to a lot of people in the press. Now, Texas Instruments, who does the OMAP, I mean, everybody knows about TI and everybody has heard about them, but they don't have nearly the same kind of presence, and the same thing for Qualcomm. I mean, you hear about Qualcomm and you think, Qualcomm Stadium out in California, and even though I don't think it's even called that anymore, or is it still Qualcomm? Anyway. Yeah, anyway. But, I mean, they're still two big companies, and not only that, but they're companies that have rather large budgets for this kind of product line. And so while we don't hear as much about them, they still are these huge, huge factors that NVIDIA needs to take care of, because this is their competition, and certainly, NVIDIA is all kinds of sound and thunder right now. But, that while Tegra 2 is certainly a product that is ahead of its competitors, not so much in its CPU performance, but definitely in the GPU. I mean, they are probably the first to market with the dual-core ARM Cortex A9 architecture, but these other guys and other giants are not going to be very, very far behind. So NVIDIA's got a huge fight on their hands, and I mean, it's not something that they're going to be able to take over. Having said that, the amount of products that will be integrating Tegra 2 in the next 6 months is truly impressive. I mean, the amount of tablets, cell phones, what have you, they're going to be shipping out millions and millions of these parts. And, I mean, the mobile market is just exploding. It's not like desktop graphics, which kind of, reaches a level and it just stays there. I mean, they're going to just be shipping tons and tons of these processors. So this is going to be a major source of income from NVIDIA, and it's something that they're going to keep their fingers on. And as we had mentioned in the CES talk, they're going to go to more desktop and notebook-centric, type power levels in these ARM processors. So we will see, dual-core and quad-core parts that are 15 and 20 watts, or possibly as high as 65 watts. And these will be high-performing parts that should give AMD and Intel a run for their money, especially with the software support that Android has, as well as what Microsoft is going to do with Windows 8, I believe.
Cool. NVIDIA will be exciting going into the future because I'm tired of these 560 Ti's already, I'll tell you that much. Alan, do you want to give us a little bit of a preview on what we have coming up next week in the world of SSDs? I know you're working on a couple of different articles right now,
yes.
Like a Zalman SSD, but that's something we've probably seen before. This Intel 310 is kind of more interesting.
This is going to be hot. I'm going to call it right now. These things are going to be all over the fucking place. Yeah. Probably not so much like fire, but just these things, I think they're just going to be just part of every flipping laptop, basically. It's just the way to go. So,
yeah.
All right. So, to test this out, got Lenovo laptop. Just regular 17-inch, halfway decent, pretty nice notebook kind of system. It's a little difference on this one, though. So, hard drive in the bottom.
Yep, hard drive. That's good news.
You got your little pocket next to it that's got your Wi-Fi adapter and whatnot with the antenna cables coming off of it. That sort of thing,
good.
Right? Yeah. Guess what? That little block there was not the antenna. That was the SSD, which I'm holding up next to an X25M. This tiny little thing that's the size of the Wi-Fi card is a full-blown SSD. And Intel was kind enough to provide us with a means to connect this, because I thought I was going to have a hard time benchmarking this guy because, you can only plug it into a laptop, right? So I can't plug it into the fire-breathing test bed and see what I can actually squeeze out of the thing. Well, Intel sent us this little adapter board that converts it to regular serial ATA. So first thing I did, slap it on the test bed and test it just like I would test any other X25M that we've tested before. Looking at the benchmarks, I couldn't tell the difference.
So a little tiny one. Now, you were saying earlier it's like a 5-channel device as opposed to a 10-channel device?
Yeah, there's only 5 flash chips on this unit, which is the same chip count that there is in the 40 gig 2.5-inch unit. The one that is typically, a much lower performer as far as IOs per second and throughput. They obviously limit the write speed, and the read speed's pretty good. This thing maxes out the bus on reads. It saturates serial ATA 3 gigabit, just like an 80 or 160 gig model would, or 120 as well.
Cool.
So whatever they did to their controller or whatever tweaks they did with their flash, maybe the chips. I haven't actually looked at the part numbers on the chips to compare yet, but yeah, the drive it's fast. It's as if you had a full blown 80 gig X25M sitting in your laptop, or desktop in the case of what I've thrown at it IOs per second wise.
Now, so this new form factor will allow. Now it will be hopefully commonplace to have both an SSD and a full-size 2.5-inch standard hard drive with a lot of capacity in it. That's kind of the goal here, right?
Yep, because you're taking no more space than you did before for the wireless card,
Right.
which is that M. Well, this is an M SATA form factor, but it's using the physical connector that is identical to the mini PCIe that you get on laptops. So, whoops, wrong side. So actually, what Lenovo has done here is they have a really tiny adapter now that does the wireless for you in the same compartment right next to where the SSD is. So, talking SSDs taking almost zero space of a notebook or netbook or what have you, and for that same kind of for an SSD that size before, like say some kind of proprietary thing for a netbook, the performance was just horrible, right? Those little tiny 16 or maybe 32 gig SSDs, if you're lucky, those things are just, they don't do command queuing. Their controllers aren't really smart at all. It's basically like you have a thumb drive just hardwired into a netbook, right? Whereas this thing is the full-blown desktop class performance unit squeezed into something.
Is that micro SATA? Is that the form factor that we're looking at?
I think the M stands for micro in this case.
Okay.
Yeah, it's either mini or micro serial ATA
so
form factor.
I guess we can assume more benchmarks and data will be forthcoming then.
Yeah, I've looked at it. All the benchmarks I ran first were just straight on, like as if it was connected to a desktop, just to give it a level playing field against everything else out there. And then I'm going to be doing some comparisons and see how it does in the laptop. And then I'll throw like a regular 2.5-inch 80 gig in there right next to it and see, okay, how's this one work in a laptop? How's the other one work in the laptop?
Right.
And I suspect they'll be pretty close. And
cool.
And I'm also guessing that with the lower chip count on this, they're probably going to be cheaper. They're easier to make. They're probably going to mass produce the heck out of the things. And
I hope so.
Yeah. Something else to consider as far as packaging wise, these are not like stacked DIMMs, so they're not like two chips stacked on top of each other or anything funky like that. There's only 5 of them on here, and this is an 80 gig drive.
Capacity is nice.
That's pretty darn good, right? That's squeezing.
Yeah, that's kind of the upgrade that people were hoping ReadyBoost would be. Plug in this little tiny thing, and hey, your system gets a lot faster. Well, now it's actually a full hard drive too.
Yeah, it's to the point, like if you get the 80 gig capacity, you don't really, you have the other hard drive sitting to the side, like for regular spinning disk, put all your big stuff on that. 80 gigs enough for Windows, applications, maybe a couple of games. That's right. And for a laptop, that's probably all you're going to put on the C drive. So it's it could very well have you covered, and then just store all your big stuff on the spinning disk right next to it, and you're good. You're just like if you were on a desktop.
All right, let's jump into some emails, and we've got a couple of voicemails. The email address, podcast@pcper.com. Telephone number for voicemails, 1-888-38-PCPer. I'll go ahead and take this first one. Is an email from Nick about next-generation SSDs. Hi, Ryan and crew. Got a new Mac Pro in December. Been waiting for the next generation of SSDs to come out before upgrading the Caviar Black Apple ships with the Mac Pro. My patience, however, is wearing thin with the Caviar slow reads and writes. How far away are the next gen of SSDs with their much talked about higher capacities and lower prices? And we kind of talk about this almost every week. Sooner rather than later, I think now at this point, now that we have Intel SATA 6 motherboards, the P67, H67 platform.
But wait. He's got a Mac Pro from December, which does not have that.
True.
Okay. So
it's not, doesn't really matter then.
For him,
he just wants lower prices.
I would say go bang for the buck, and probably that 120 gig X25M. I think that's what's selling for the best bang for the buck right now. Even capacity for the buck, for that matter.
Yeah, I think I would look capacity for the buck there. I don't know. Are the Vertex 2s and stuff like that? The SandForce drives, are they competing, or are they still a little bit higher than Intel now?
They've generally been riding a little bit higher, like all the time. Intel keeps undercutting them with something. Right. They started to beat them, and then Intel came out with that 120 gig model and just cut the floor under everybody again.
Right.
So I would go either camp for his application. Nick, either one, just SandForce or Intel. best bang for the buck, or best capacity for the buck for what you need for capacity. And just move that caviar over one bay in the Mac Pro. Keep it in there. Stick all your big stuff on there, right? So then you've got your SSD and your big stuff. But don't wait for SATA 6 specifically for your Mac Pro, because you're not going to see, probably most of the speed benefit you're not going to get, because you're bottlenecking it on throughput. Right. You'll put a much faster drive behind an interface that only supports half the speed. So you'll end up spending a price premium for a SATA 6 gigabit drive that you will not use for that price premium.
Fair enough. Jeremy, you want to take our second email?
Well, we've got an email from Brandon about 2 different but popular video cards. Good evening, gentlemen. I've got 2 quick questions for you. Between the MSI Hawk Talon Attack Geforce GTX 460 and the Radeon HD 6870, which is a better card for the money? My second question is, I only have a 600 watt PSU, and what I'm wondering is, am I going to have a problem running either of those cards with my current power supply? Love the show. Keep up the good work. Second question first. No, you won't, unless it's a crap power supply, and I doubt you bought one. Between the two, Quick Peek has the GeForce at 229 versus 239 being the cheapest HD 6870 that I can see.
It's a trick question, though. It's a trick question because the GTX 460 for 229 is only $20 less than a GTX 560. It was just released and is for sale now. And even the Hawk Talon Attack 1 gigabyte card is running at 810 megahertz, and you can get the MSI same exact cooler on the 560 that runs at 880 megahertz with more shader cores for $20 more. So,
and there might be a 1 gigahertz model from what you said.
Yeah, and there might be, there's supposed to be, quote, a gigabyte 1 gigahertz model if you can find it, which I have not been able to yet. So, in fact, there is a 900 megahertz gigabyte version for $249. So, there are a lot of 560s around. They're in stock. They're not being overpriced. And I think at this point, buying a GTX 460 for $229 is probably the wrong move. So, third email, Alan. It again mentions SSDs. We got a lot of those this week.
All right, email from Frank about, go figure, SSDs. Hi, guys. Love the show. You guys are killing it. You're welcome.
We're that bad. We are just destroying it.
We are.
Yes, destroying it.
We're dismembering and throwing it, the corpse, into a bonfire.
It's pod corpse.
All right, so let's see. My questions are about SSD performance. I'm an early adopter and bought the first X25Es when they came out and love the performance. I'm a game developer and do a lot of coding and media stuff. The performance boost has made a tangible difference in my team's productivity. Oh, yes, especially over a spinning disk. Cutting to the chase. A few episodes back, you suggested to a listener that for non-RAID configs, you probably use Intel SSDs. I've always base purchased on megabytes per second, as that seemed to be the most discussed performance benchmark. The specifications indicate that megabytes per second wise, SandForce should be equal, if not superior, to Intel. Are you recommending Intel because of superior IOs per second? Answer to that one, yes. And that the write speed limit, even though it is a limit on Intel drives, is not that big of a deal unless you have to be getting data from somewhere if you're trying to write it at greater than 80 or 100 meg per second, where that's going to be your bottleneck.
Even if you're compiling a project as complicated as maybe a modern PC game, you're still not probably writing at that level.
Right. If you do manage to hit 80 meg per second writes, it's probably happening with a bunch of small files, which an Intel will be superior to a SandForce on.
Okay.
Because, again, you're back to the IOs per second and handling of really small files. All right, so to continue, if so, would you say that in general IOs per second are more important in scenarios involving lots of small files, whereas megabytes per second should be used for scenarios with a few large files? Yes. And the cutoff there, I would say, 20 meg, 60 meg, something like that. If you're putting huge movies and stuff on this thing, just moving around huge files like media, that kind of thing. And you're writing, copying from the drive and right back to the drive, SandForce is going to beat Intel. Right? You can get that. That kind of thing comes right off of our file copy test for any given solid-state drive review at PCPer. You can pretty much just look right at those charts for any drive and just go right off the file copy test. That's going to be your high sequential, high large file throughput kind of thing.
Sure.
But for all the small stuff, that's where you get into the IO meter benchmarks that we do and see, because those benchmarks are throwing a bunch of really small stuff at the drive, typically like 4K, 8K, and seeing just how much they can handle. And on top of that, they're doing it multi-threaded, right? So we do, different queue depths. So in other words, we'll throw 4 of those commands at the drive simultaneously so that the drive can accelerate that if it's capable.
Gotcha.
SandForce does do that. It's good. It was the second guys after Intel to actually ramp up as you pile more and more stuff on the drive. However, Intel still beats them. Intel controller still a little bit faster at that. Last part. Any planned update to the SSD decoder? It's awesome. Thanks. And yes, I'm doing. Actually, I update the SSD decoder probably like every 2 days. But it's just that I have to polish it before it's fit for going up again with like change notes and all this other stuff. So there's going to be one last big update before we start seeing the wave of serial ATA 6 gigabit stuff. I'm trying to reformat the decoder into something that's going to like make heads or tails out of that. Trying to figure out how I want to subdivide those sections out to say, okay, this is all the 3 gigabit, and here's all the new 6 gigabit stuff if I want to put it off to the side or mix it in.
We'll figure it out.
Yeah, we'll figure something out, but that's inquiring minds want to know, but it's coming. Anyhow,
did you also answer the middle part there, number 2, just real quick?
Oh, okay, hold on. Yeah, I skipped it. Whoops. Because my work involves a lot of programming, it'd be great to see a compiler benchmark in the SSD suite. Then he goes on to say perhaps a large Linux distro. Sounds like it'd be a good test case, but I'm not sure, as I'm not a Linux guy, so I don't know what he's compiling in. Probably C.
No, he's just using it as an example, yo.
Well, right, but his work involves a lot of
something easy
programming.
you can compile that is a large project and use it as a benchmark.
Here's the thing: he's doing a lot of programming, but he's not under Linux, so I don't know. We might have to look into some kind of benchmark. That would actually be a very good small file benchmark if we can come up with something.
I think that's all he's saying, right? Is that?
Yeah, because compiling pulls from a bunch of really small source files peppered all over the drive usually, and it's just random read heavy when you're compiling a job, because the executable that comes out is just like one small file generally, or one large file. It's just continuous, right? So the process is similar to like a boot process where Windows is calling from thousands of different places on the drive at the same time trying to boot. But yeah, it was something worth looking into. We'll check it out.
All right, last email, Josh. Take it away.
Do I have to?
Yes.
You have to do the duck
but it's
lips
so
too.
long.
I know. That's why I picked you for it.
Words in it, like block
Acronyms too.
and do and Africa. Okay, it doesn't
Just
have
read
Africa
the
in there.
damn email.
Email from Gabriel about UEFI and SSDs. Better than something else in STDs. Anyway, hello, Ryan and crew. Can you clarify some info about setting up a UEFI install of Windows 7 x64? I want to build a totally new system using a Core i7-2600K, but I want to get a motherboard that supports a UEFI boot from a GPT partitioned SSD, but I also want to use native sector block sizes at 4K like the new SSDs do internally, so I don't have to use 512K ones. I don't know what SSDs can use or benefit from using GPT partitions, but would like any info or thoughts on this. Basically, I want to be 100% UEFI to take advantage of eliminating all legacy BIOS bottlenecks if I can get away with it, since I'm going to buy all new parts either way. Can you recommend what motherboard for the Core i7-2600K has the best UEFI implementation, along with the SSD and GPU that are going to let me pull off a rapid boot type setup like what OEMs were showing at CES? Or just tell me if I'm better off getting an OEM model that is already set up without a legacy BIOS. Thank you for the time. Apologize for the run-on sentences. Love the show. I hope everyone with a cold from episode 138 feels better soon.
Awesome.
Anyway, that was pretty much all.
Boy, you know what? As I'm going to have to pass off the UEFI and GPT partition stuff to Alan because I have no clue.
The only motherboard that I know of that has a complete EFI implementation are the Asus P8, P67 boards. I think there's at least 1 or 2 gigabyte boards that have it, and I think MSI it's coming.
It's coming. I'm not sure if it's on the Marshall or not.
Yeah, I don't know.
Okay, so you guys want the UEFI skinny as it relates to storage?
Yeah, give us the 60-second rundown now.
Okay, so UEFI in general is nice GUI based BIOS, like next generation non-text kind of thing. Okay,
use a mouse.
Yeah, the Marshall does have it.
Yeah, it's got a mouse. As it relates to storage, it enables you to have GPT-based partitioning and boot from those GPT partitions. Now, why the heck do you need GPT and what's that? Well, Master Boot Record, MBR, the old school format, only supports up to a 2 terabyte partition. So if you want to boot off of a drive larger than 2, you need to have GPT-based partitioning. Works a little bit different. Does not use a master boot record. It just puts like a generic thing in the master boot record that says, hey, I have a partition. It's using the whole disk. But it's not actually what's the OS is going to follow or anything is going to follow. It's just like a placeholder. So GPT gives you a lot more flexibility. You can have a whole bunch more partitions, a bunch of different partition types. But it doesn't start like right at the beginning of the disk anymore. It shifts it over. Now, he's asking specific to like 4K, alignment and stuff like that. First of all, SSDs do not like just to be aligned to a 4K boundary. The only time you see 4K boundary alignment is for advanced format spinning hard disk drives, the new ones that have, instead of individual sector parity, they have 4K sector parity, right? So you wouldn't want to write single sectors to those drives because it will, just like a RAID, have to read the entire 4K sector, modify just the one sector out of it, and rewrite that back to the drive so it goes slower. Okay. SSDs are similar to that, but the block array size of flash memory on an SSD is not 4K. We're talking more like half a megabyte to a megabyte, depending on like which nanometer flash, all that kind of stuff. Best place to look for those numbers if you want the specifics is the Lehi, Utah Intel /Micron trip from what was it, last February that I did? We have an article on that. There's an article on that up in the storage section of PC Per. So you want to be on like at least a 1 megabyte multiple, right? So here's where you don't have to worry about anything. First of all, if you're formatting with Windows 7 or even Windows Vista for that matter, with Master Boot Record, it formats, the first partition does not start until at least a 1 megabyte out. So you're good. It's an even 1 megabyte boundary, not only divisible by 4K, but divisible by 1 meg. And for UEFI, or not UEFI, for GPT, let's see, if you have like a Windows partition, there's that little 100 megabyte, the little 100 megabyte recovery thing it puts at the beginning, right? Just as an example, that guy starts at sector 2048. And since the sector is a half a K, it's 1 megabyte, right? And then the first OS partition, it doesn't start until like 100 meg out, obviously, because you had the 100 megabyte partition, but it's also on a 1 megabyte boundary. Okay, as a matter of fact, I think they go on like 2 megabyte boundaries, just from my experience. And then that applies to everything. Even if you're in Windows and you made a GPT partition on like some other, like my array, my 16 terabyte array, it's also on a multiple of, I think, 2 megabytes. I looked at it. Actually, I'm looking at it right now. So you're covered, basically, for any kind of...
good.
Yeah, you don't have to don't do any kind of weird like say Windows XP used to have to use diskpart and align. You have to use the align command to do this kind of special thing where it shifts it over. You don't have to worry about that anymore. Little side note, though, if you're only using SSDs, if you don't need GPT, don't bother. Because GPT is kind of... You don't really need the other partitioning scheme unless you want to make more than 4 partitions under a master boot record partitioning scheme on your SSDs. I generally like to stick with MBR if I can. The only reason I go over it is if I'm going over a 2 terabyte partition, because it complicates other stuff that you might not be thinking about, like data recovery, for example. Not all the data recovery tools can gracefully handle GPT yet, right? Because the partition actually starts at a different place. The pointers are all different. So there's a lot of legacy-ish kind of like hard drive recovery tools that will just choke if you throw something at it. I had to go through a couple, jump through a couple loopholes for Ryan, our buddy, who had a RAID fail on him. Yeah.
Oh.
So we had a 4 terabyte RAID fail, and it was GPT. And in order to be able to read it, I had to go through a couple extra steps just to lock in or zero in on that data on the start of the partition and everything else. And that was even with tools that were supposed to support GPT, and it was still tricky. So, don't do it unless you...
And if it's tricky for you, it's near impossible for the rest of us.
It was tricky for me. It was. I had to sit there with the calculator for like 45 minutes doing like sector math just to figure out where the partition started.
Hey,
it was
better you than me.
Well, I knew my linear algebra would come into...
I actually had to use linear algebra. Yes, I did. That was the one time ever.
Well, hey, that was a terrific explanation of GPT. A horrible estimation of 60 seconds, but a wonderful explanation of GPT. Let's get to a couple of voicemails since I already had them in here anyway. We have the first one asking a question about OS performance and hardware performance.
Hey, do you think the operating system matters in terms of performance, or is it kind of all like level playing like right now with perspective, or the Windows versus Linux versus whatever OS? Do you think it's all level playing, or do you think it's open games so they can take advantage based on OS performance? Thanks a lot. Bye.
So it seems like a simple question up front. Does the operating system matter in terms of performance? I assume he's talking about the type of hardware that we're talking about here, processors and motherboards and graphics cards. It's kind of like a really complicated question, though, if you really want to get down to it. The operating system matters a lot. You look at how important software is to performance. We talked about last week the Sandy Bridge graphics basically not functioning on Linux. Is that an issue of software? Is it an issue of hardware performance? It's a mix of both, right? Because the software doesn't allow you to access the full performance of the hardware. We've seen different versions of Windows take very different advantage or increased advantage of hyper-threading, multiple threads.
Hey, dude.
Josh.
Hey, dude. Hey, dude.
So I say the answer to that is the OS still definitely does matter.
Hey, do you think the...
I don't know. I mean, Josh, anything else? I mean, to add to that, I mean, operating systems matter still, definitely.
Yes, they do. Just because, some support some of the, crazier things like SSC3, SSC4, and then you got other things like... I can't remember exactly what that certain situation was that OS X was horrific at, like 4 times slower than Windows Vista at the time. I think they probably fixed that. But yeah, OS does make a difference. But as long as you do enough service packs and things, usually they fix those issues. Yeah. But again, the overhead of something like, of a very basic Linux compile, I mean, it's going to blow everything else out of the water if you just focus it